Okay, here we go. So in a stats class, 57% of the students eat breakfast in the morning, 80% floss their teeth, 46% do both. So here we go, one out of 1,000 on the thousands table. 57% eating breakfast, 800 flossing. Why do you floss if you hadn't eaten? I don't know. So 20% don't floss, 43% don't eat breakfast. Okay, 46% do both. So it asks, what's the probability that a student from this class eats breakfast but does not floss their teeth? Okay, so they eat breakfast, they don't floss, 11% B. What is the probability that a student from the class eats breakfast or flosses their teeth? Okay, so this plus this plus this, or 90 taken from 1,000. Okay, so that's 91%. 340, 460, 110 equal 910, or 91%. Or you could have subtracted 1,000 minus 90 is 910. Okay, number 3. 5 juniors and 4 seniors have applied for 2 open student council positions. They'll pick 2 members randomly. What's the probability that both are junior, or, which we're going to add, both seniors? Okay, so we have a independent, 2 events happening here plus 2 events happening here. So let's look at juniors first. There are 5 juniors. There are 9 people total. So juniors picked as 5 nights. How many juniors are left? Correct. There are 4 out of 8 people. Or add 4 seniors out of 9 times 3 seniors out of 8. Okay, so we can multiply all that together if we'd like. So we're going to say 5 nights times 4 eights plus 4 nights times 3 eighths equals 0.44444444. That answer is B. Okay, that answer is B. Okay, so that's 0.4444. Okay, we took each event, 5 juniors taking 9, there were 9 of them, but we take 1 out. That means we only have 4 left out of 8 people. Same thing with the seniors. We have 4 out of 9 are seniors. We take 1 away. Whoops, sorry, I'm not on the screen. Now, there we go, sorry. So there are 3 seniors left out of 8 people. So we multiply those 2 together, both juniors, both seniors, and then we add them. Okay, a fair coin has come up heads 10 times in a row. The probability the coin will come up on the next flip is B, 50%. There you go. According to the national television or whatever, it's 56.5% of own a computer. What is the probability that 3 owned it, at least one owned a computer in 2001? Okay, at least one. At least one. Okay, so we have a fixed number of trials. P is 0.565. So we're doing, this is binomial. So we're doing 1 minus a binomial. CDF of 3.565 and 0, because we're doing the complement because it said at least. So here we go. 1 minus second distribution, binomial CDF, and this is 3.565. Wasn't it 565? Yeah, 565 and 0. And that answer is about 0.918. That answer is E. See my number, 918768. I rounded up to 918 because they have 91.8. According to that same group, 0.505 of U.S. households, so P is 0.505, had internet access. What is the probability that 4 randomly selected all had internet access? Okay, so all 4 had internet access. So that's 4 things happening. 0.505 times 0.505, 505 times 0.505 times 0.505. In other words, 505 to the fourth. 0.505 raised to the fourth equals about 6.5%. Okay, that answer is A. .505 to the fourth. Which of these is a binomial? Okay, means fixed number of trials. All right. Fixed number of trials. Independent, 2 possible outcomes, and probability stays the same. So the number of people we survey until we find someone, oh no, that's geometric. The number of people we survey until we find 2, no, that's neither binomial nor geometric. The number of people in a class of 25 who have taken statistics. There's your binomial model. Okay, this is not the number of aces in a 5-card poker hand because every time you deal a card, the probability changes. Okay, every time you deal the cards, your sample size shrinks. So that's not probable. And the number of soda students drink per day. What? It doesn't matter. The answer on this one is C. Okay, which of these is geometric? The number of people we survey until we find someone, success, who has taken statistics. That was an easy one. Okay, Batco, a company that sells batteries, claims that 99.5% of the batteries are working order. How many would you expect to buy on average to find one that does not work? Okay, so this is our success. This is geometric. Everybody understand, this is a geometric model. This is a geometric model. Our success is one that does not work. Here, P is going to equal 0.05. Oh, 0.005, sorry. Thank you for you math people out there. This is Q. This is P. With a geometric, this is our success. The first one, how many would we have to expect to buy? So we come here to geometric distribution. Expected value is 1 over P. So we do 1, divided by P, which is 0.05. We'd expect to buy 200. Oops, I almost marked 2,000. We'd expect to buy 200. Everybody understand where that just came from? I hope so. It's 1 over P. It's 1 over P. Also known as 1 over 0.005. Because that's our success. We want one that does not work. All right, last one I'm going to do, then I'm going to cut this video off and take a break. I've been doing this way too long. Some marathon allow 2 runners to split. So these 2 ladies are going to split their marathon. Standard deviation of 2. Oh, what's the standard deviation of their total time? Okay, standard deviation of their total time. So 4 plus 2 divided by 2, right? No. 4 plus 2 is 6? No. Okay, so we take square root of 4. Excuse me. Square root of 4 squared plus 2 squared, which is the square root of 20. Second square root 20 enter, about 4.5 minutes. Okay. Square, add square root. Square, add square root. It's about 4.5 minutes. Okay, that's enough.